Hello and welcome back. This is part 5 of our series on searching and sorting algorithms, and today we will be covering bubble sort. What is bubble sort? Bubble sort is a comparison-based sorting algorithm. It works by repeatedly swapping the adjacent elements if they are out of order. And the concept is simple, just like bubbles rising up in water. The largest elements bubble towards the end of the list with each pass. It's one of the simpler algorithms in sorting, and it is often used as an introduction to the sorting techniques. However, bubble sort has a time complexity of O of n squared, which it shares with algorithms like selection sort. This makes it less efficient than other algorithms for large datasets, but it's still a great way to understand the basics of sorting. Now let's look at the code breakdown. So first of all, we can see the outer loop. The outer loop will be used to iterate through our array. We can also optimize the outer loop by adding another variable called swapped, and it will check if our array is fully sorted or not. If it is, our outer loop will break and we will end our process, therefore reducing the time complexity for the best case. Now let's move on to the inner loop. In the inner loop, we can see our index j, which will also start from the first element, and it will continue checking the conditions to see if we will have to perform a swap between two elements which are out of order, and our inner loop will iterate until the last position or the last index of our unsorted portion of the array. So in other words, our inner loop will not traverse through the sorted parts of our array or sorted portions of our array. That's why we declare the condition as j has to be less than array.length minus 1 minus I. Now let's move on to the next part. In the next part, we can see the condition checks. Here, we are checking if we will have to perform a swap or not. If the condition turns out to be true, we will use the help of our temporary variable to perform a swap between the two elements of the array. Now let's look at the visualization example. On the left side, we can see an array with unsorted elements. On the right side, we can see bubbles with various numbers indicating the elements of our array on the left side. So first, we will have our outer loop. I will be at 0, and we will have our inner loop. J will start at 0. We add 1 to j, and it will be used as index when we are checking the two elements, the element at j and the element at j plus 1. When we check these two elements, we can see that they are not out of order, meaning that we will not be performing any swap. Moving on, j gets incremented. J is now 1, and j plus 1 is now 2. When we compare these two variables, however, we can see that they are not in order. So we will perform a swap. So 15 gets swapped with 21. Okay, after the swap, we will move on by incrementing j. J will be 2, j plus 1 will be 3. As we check these two elements, we can see that there's nothing wrong with it. So we will move on. But here, however, we can see that something is wrong, and we will have to perform a swap. Okay, now let's move on by incrementing j once again. J becomes 4, j plus 1 is 5. As we compare these two variables, these two elements, we can say that we will have to perform another swap. As you can see, the largest element of our array has reached the end of our array. So the bubble 32 will float up to the water's surface. Okay, so this is the second iteration of our outer loop. That's why I gets incremented to 1. J will start at 0, and this process will repeat until the whole array is sorted. So right now we don't need to do any swapping at the moment. Let's move on. J gets incremented. We check with the element just in front of J. Still, we don't need to perform another swap. Let's increment J again. But now we see that we will have to perform a swap on 21 and 10. Okay, let's increment J. J is now 3. J plus 1 is now 4. And by checking these two elements, we can say that we will have to perform a swap. So now, as we look at our array, we can see that the number 21 has reached its correct position, meaning that bubble 21 will float up to the top. And following 21, we can also see that 16 has also reached its correct position. Okay, so bubble 16 also floats to the top of the surface. Here we will move on to our third iteration. Okay, I gets incremented. J starts from 0 once again. We check these two elements. Still doesn't need to perform a swap. We move on. We check these two elements. And here we can see that we will have to perform our last swap. Okay, let's perform a swap. Now we can see that our array is already sorted. 15 goes up to the water surface, followed by 10 and 12. And due to our configurations of our inner loop, we will still check these two elements. But we won't be doing any swapping, of course, because it's already sorted. So there's one thing left to note. As you can see, we might think our code has ended or our process has ended, but due to our implementation, I used the outer loop without any checking of whether our array is already sorted or not. Therefore, our outer loop will keep on running and our inner loop will keep on checking, making our code run a lot slower than an optimized bubble sorting algorithm. So maybe in the future videos, I will include a bubble sort algorithm using the swapped variable or Boolean swapped variable that will control the outer loop, and by using that variable we can optimize our code and optimize our time complexity when it comes to certain scenarios. Now let's talk about the time complexity. So time complexity of bubble sort algorithm is O of n squared in all cases, best, average, and worst. Because it involves two nested loops, the outer loop will run n times, and the inner loop goes through all unsorted elements in each pass. In the worst and average cases, bubble sort performs O of n squared comparisons and swaps. However, bubble sort can be optimized, and it can be done by using a swapped flag. We can reduce the time complexity to O of n in the best case, like when the array is already sorted. If no swaps occur during the pass, the algorithm can stop early, saving time, unlike our current implementation, which will still iterate even if our array is already sorted. Finally, let's discuss the space complexity. Bubble sort's space complexity is O of 1. This means it only uses a constant amount of extra space, regardless of the input array size. The only extra memory it needs is for the array itself and a temporary variable, temp, for swapping elements. There are no additional data structures, which keeps the memory usage low. So that's bubble sort. It's a straightforward algorithm with a simple mechanism of bubbling up the largest element, making it a great introductory sort. However, its O of n squared time complexity limits its use for large datasets. Despite this, it's valuable stepping stone towards understanding more complex sorting algorithms. Now let's write the code for our sorting algorithm. So here will be our main method. We need a parameter, which will be our array. So first of all, there will be an outer loop. Okay, here is the outer loop, and we can write our inner loop. The inner loop also starts from the first element. We'll have to make sure that our inner loop doesn't travel through the sorted portion of our array. So in our inner loop, we will perform condition checks, and if we need to swap, we will perform a swap between two elements by using a temporary variable. So here we go. Here's our sorting algorithm. In the next videos, I will also add a more optimized bubble sort algorithm. Here we will write our test array. I think I've prepared our array. Okay, here's our test array. Now let's check if our sorting algorithm actually works on our test array. First we will sort our test array, then we will print it out. There we go. Let's run the code to see if it works. As you can see, the code will run smoothly as expected, and our input array will be already sorted. So this will be it for today. Thanks for watching, and stay tuned for the next video in our series on searching and sorting algorithms. And make sure you like and subscribe to stay tuned whenever a new video comes out.